Now, this video is about energy stores and questions in your exam you can get about them. Now, energy is conserved. Now, conservation, to conserve something, means to keep it the same. Energy cannot be created or destroyed. It can only change type and move to other objects. What I mean by that is if I've got 100 joules of energy, I can change it between the different types, or I could give it to something else, but there must still be 100 joules of energy at the end. Now, the 7 different types of energy you need to know. You won't be asked to list them. You'll be asked to use them in a context, so the question will help you remember them. Thermal energy is also known as heat energy, so anything that's warm or hot has thermal energy. Gravitational energy is for anything that's up high. Chemical energy is energy that chemicals store. It's in your food, it's in fuels like gas and coal. It's also in batteries, because batteries have chemicals in them. Kinetic energy is movement energy. So anything that's moving has kinetic energy. Elastic energy is anything that stretches and squashes. Magnetic energy is magnets. And nuclear energy is, well, nuclear energy. Now, these last two don't come up too often because there's only specific examples they come up in. Magnetic's very easy to identify because there must be something to do with magnets. And nuclear energy generally only comes up in stars are powered by nuclear fusion or nuclear power stations. But as I said before, if I have, say, 100 joules of kinetic energy because I'm moving and I then stop, I am losing that kinetic energy, but the 100 joules must go somewhere. I must change it into thermal, heat something up, or something like that. So I just switch between these. Now, I'll have a look at some exam questions where these come up. So notice that I've got rid of parts A, B, and C. We're going straight to part D. And parts A, B, and C were about a toaster. So then, part D. Complete the sentence, choose answers from the box. When bread is lowered into the toaster, a spring is stretched. The stretched spring stores something energy. So I need energy that something stretched might store. So it's elastic. So I copy that onto the line. And it says elastic potential, so I'll write the full thing. After the bread is toasted, the spring makes the toast move upwards. As the speed of the toast increases, the something energy of the toast increases. So it's talking about the toast moving. So that's kinetic energy. So that's quite a nice question because it gives you big hints. A spring is stretched to make you think of elastic. The toast moves to make you think of kinetic. And it gives you the words to pick from. Now, this next one. A student investigated how the distance travelled by a trolley from the end of a ramp varied with the total mass of the trolley. And then we've got a diagram of what they were doing. I'm skipping straight to part E. Parts A, B, C, and D made you do energy calculations and talk about forces and things like that. So when the trolley is released from the start position, energy is transferred in different ways. Complete the sentences, choose answers from the box. As the trolley moves down the ramp, the trolley moves down. That's a hint as well. Down the ramp, the trolley accelerates. There is a decrease in the trolley's something energy. Well, it's speeding up, so it's gaining kinetic energy. It can't be that. But if I go back to the diagram, as it moves down the ramp, it is losing height. If it's losing height, it is losing gravitational energy. There is an increase in the trolleys, and because it's accelerating, it's getting faster, it's moving faster, so it's increasing its kinetic energy. After leaving the ramp, the trolley slows down, so it must be losing kinetic energy again. But the sentence says there is an increase in the something energy of the surroundings. So although the trolley is losing kinetic energy as it slows down, it's hitting the air around it, and it'll be giving the air around it thermal energy. Now, it'll only heat up a tiny bit, so you wouldn't notice, but the friction is causing that little bit of heat, and that's why it's thermal energy. Now, those are two questions where we got given options and had to fill in the sentences. Let's look at one where we have to do it all ourselves. So, figure 1 shows a battery-operated remote control car. The car's battery contains a store of energy. As the car moves, energy from one store is transferred to another store. Describe how different stores of energy change as the car moves. So they're giving us loads of clues in the question. It is a describe question, so we've got to say what's happening. But it does tell us the battery contains a store of energy, and it tells us the car then moves. We know movement energy is kinetic energy, so we know we're going to be mentioning that, but we need to name this store of energy in the battery first. So batteries contain chemicals, so we start off with a chemical store of energy in the battery. So the battery contains a store of chemical energy. Now that actually doesn't get me a mark because it does say describe how different stores of energy change, and I've not talked about a change yet. So the battery contains a store of chemical energy which decreases. The battery will lose chemical energy, and that chemical energy that it's losing will become the kinetic energy as it moves. The battery contains a store of chemical energy which decreases, and the kinetic energy store of the car increases. So I've clearly said two changes. It does say they want the energy changes to be described. So I've said what the types of energy are, but I've also said that the chemical store decreases, there's one change, and the kinetic energy increases, there's the second change. 2 marks. Now another one where we're not given options. So figure 2 shows a gas boiler used to heat the house. Describe how different energy stores are changed by the boiler. Now, there are clues in what I'm given in the diagram. I'm told it's a gas boiler, and I'm told fuel is going in. So the fuel is the gas. Don't know why I've put 2 S's on that. I'm also told that the cold water becomes the hot water. So if it's heating up, it must be gaining thermal energy. I'm also told hot exhaust gases. So I must be heating up the air inside it as well. And this is 3 marks. So again, it says describe how the energy stores are changed. It wants the changes. So I've got chemical energy in the fuel. So the chemical energy in the fuel decreases. There's my first change. And that causes the thermal energy store of the water. And now I could put and the exhaust gases, I could put and the metal the boiler's made out of, and I'm just going to call it the surroundings, but it doesn't actually matter what word I use. But for my 3rd mark, I must make it clear I know that it's heating up the surroundings as well. So the chemical energy in the fuel decreases. This causes the thermal energy store of the water and the surroundings to increase. So I've clearly said the changes, and I've said 3 marks worth of changes. I said the chemical energy in the fuel's decreasing. I said the thermal energy of the water is increasing, and the thermal energy of the surroundings is increasing. 3 marks. Now the last one, oh no, I don't think it is the last one. I think I've got 2 more. The diagram below shows a wood-fired hot tub. Describe the change to the stores of energy of the wood, pipe, and water as the water is heated. So again, I've got to say the changes. I can't just name the energies. So the wood starts off with chemical energy, but I've got to say the change. So the chemical energy is decreasing because its energy is becoming the thermal energy. The pipe will heat up, so thermal energy is increasing. And the water is also heating up, so the thermal energy is increasing. I have clearly stated the changes. I've not just named the energies. Last time this was on a mock exam, students often just named the energies, so they got no marks because they didn't say the changes. Now, last one. Astronauts have been to the moon. Astronauts moved around the surface of the moon in a lunar rover. The photograph below shows a lunar rover. Not all of the energy from the batteries was usefully transferred to kinetic energy of the lunar rover. Explain why. So we're being asked, where is this missing energy go? We know the battery holds kinetic energy, but not all of it is becoming kinetic energy. That means some of it is wasted. We want it to become kinetic energy. We want it to make the lunar rover move. So anything else, the energy is being wasted. That's 1 mark. We get the second mark saying how it's being wasted. Anything electronic or anything with friction between wheels and the ground will cause thermal energy, which we don't always want. So some of the energy is wasted as thermal energy to the surroundings. So that question did part of it for us. It already told us it was becoming kinetic. We just had to identify the wasted. But that's 2 marks. 1 for saying some energy is wasted, and 1 for saying what is the energy and how it's wasted. And that's how you do questions on energy transfers.